Hello Year 12, I am making this video today for you just to go over some of the key points of the water balance with you. But after you've watched it, let me know if you found it useful or if you found it supported your learning, and I can make some more of them for you if you would like. So I'm going to quickly recap the water balance task that I set you last week. So hopefully now on your screen you can see the water balance worksheet and me in one of the corners. That was weird. I went a bit David Brent there. So the water balance sheet is very straightforward. The data actually came from one of the textbooks, and on this sheet all you have to do is fill in the final two columns. The rest of it's already done. So just to clarify the purpose of the data. Precipitation, as you will have seen from the PowerPoint, which is coming up on your screen now, the optimized kind of model of the water balance, as expressed in the graph, shows you that during the year, the level of precipitation in this part of the world is relatively stable, but increases in the winter months, whereas the evapotranspiration is low in the winter and higher over the summer months. And at this latitude, we should see more extremes because we are quite far north, and so we have much longer summer days than we do in winter because of our latitude and the tilt of the earth and everything else. And that means in the winter, the sun doesn't rise very high in the sky, we don't have that many hours of daylight, it's not as warm, and that limits the opportunity for evaporation. So during the winter months, we should be in water surplus, as in the soil should have more than enough water in it to support this ecosystem, okay? As we move into the summer, theoretically, the amount of evaporation should overtake the amount of precipitation. This is a model, so it doesn't always work like that. And that then means that the level of water in the soil decreases. After a period of recharge, the soil, as it goes back into December, goes back into surplus. So, the water balance is really important for the Environment Agency and other planning bodies, including councils, because by looking at this data over long periods of time, we can start to work out trends. We can start to work out where flooding might occur, and we can start to see the impact of some of the man-made changes we make to drainage basins. For example, in the River Wye and in many drainage basins around the UK, some deforestation has taken place. Now, deforestation isn't a new phenomenon. It's been happening since the medieval land clearance period, and lots of clearance will have an impact in a drainage basin. It will increase the rate of runoff. So, part of your task is to not only look at this data and describe it and everything else, but also to be able to interpret some of the key themes that we can see. So you only have to fill out the final two columns. The storage is quite simple. You fill it out. The storage is what is being stored in the pore spaces in the soil, okay, in the gaps. So you do the precipitation, the rainfall, you minus the runoff, because the runoff is the water that has run away over the surface of the soil and isn't being stored. Hopefully it's running to the river where it will be carried out to sea. The evaporation or evapotranspiration is the water that's evaporated from the plants or from the surface, and therefore, again, isn't held in storage. So what you do is you take precipitation, you minus runoff, minus evapotranspiration, and that tells you how much water is being held in storage in January. So in January, actually, the amount of water held in storage was in negative numbers because there was more loss than gain. Okay, now that's not so important in a water cycle of a drainage basin, you know, in the drainage basin, if it's only happening occasionally. But if you're seeing a consistent pattern over a year or 2 years or 3 years, you might then end up in drought conditions. In the UK, I know in my area, I got a letter saying that because the winter and the year before this year was drier, that if we didn't get a lot of rainfall over this winter just gone, then they were going to have to go on to drought measures. So again, hose pipe bans and things like that. But actually we had a really wet winter, so hopefully the soil will have recharged enough to cope. After that, so you complete that column, then you have your runoff as a percentage of precipitation. This tells you a lot about a drainage basin. As I said before, if there's lots of runoff, that could be caused by lots of deforestation. And if there's lots of runoff, that is going to reduce the river's capacity to cope with the amount of water in the drainage basin. Naturally, rivers are the size they need to be to cope with that drainage basin, right? To cope with all the water. That's why the Mississippi drainage basin is much bigger than the Thames and much bigger than the Chubut. But we have edited our basins, we've urbanised, we've deforested, we have rerouted rivers. In Victorian times, they did that on the Tees and things like that. So we've changed the system. So knowing the amount of runoff is important to identifying some of the factors that might affect that drainage basin. So we can see here that some of the figures are quite high. There's quite a high percentage, 98.2% of the rainfall that falls, or the precipitation that falls, ends up flowing over land. Now that's going to mean that the water is going to get to the river very quickly. So that's going to increase its risk of flooding. So once you have filled in your table, you were then asked to graph your findings. So I'm just going to click on the data. Now, I opened this file and it opened it into numbers because I use a Mac. If you use a PC, it will potentially look a bit different because this didn't look like this in school. Now, part of this task is getting you to think about selecting the right data to create the right graph, okay? So because we're trying to make a model of a water balance graph, you only need the precipitation and the evaporation, okay? Now the River Wye is quite interesting because the evaporation rate actually never overtakes the rate of precipitation. And again, it's up to you to think about why that is, what causes that. And again, you might think if it's geographical location, it's in Wales, it's more hilly, it starts in Plinlimmon, on Plinlimmon I should say, and therefore will have a different optimized water balance graph than some other rivers would. So then I wanted you to think about some of the reasons for that data in question 4, which I've kind of gone through. And then I wanted you to research the River Wye's drainage basin in a little bit more detail and think about, do you think it needs managing, and the potential issues. And again, I've alluded to lots of those. So that was the water balance. Today, I asked you to have a look at the exam questions. So the first exam question was a 4-marker from the old A-level. Now, this was actually when we had ASs, that's why it's a kind of simpler way of approaching an exam question. You won't find complete the fact file questions in your A-level, but it's good just to test your knowledge. Okay, so you do that one, 4 marks, and then afterwards, this one is a real 6 marker from the new A-level. And what I would say here is I'd like you to answer this and then look at the mark scheme, mark it to how you think you would score using the mark scheme. And then if you upload it to the class notebook, in the class notes section, I will then have a look at it and see if I agree with your marking, okay? Before you do that though, what I would say is it's an interesting question because there's quite a lot of information in it. First of all, you've got the map, and then you've got the 2-line graphs, and you've also got the blurb. Now, where a lot of candidates lose marks in exam questions is they are panicked because they're short of time. So they read the question using figure 1, analyse projected rainfall change in Africa. Right, let's go. And they just look at this and they don't look at the blurb that goes with it. The blurb gives you lots of clues about how to frame your answer. So it's so important that you read that information. For example, this question is all about change, rainfall change. And also some of the changes are projected, so they're in the future. So the map shows how rainfall totals are expected to change. Where they're darker blue, they're in positive. Where they're in yellow, it's anticipated that that area will get drier. Now, this one gives you country specifics, whereas the 2-line graphs give you an African average, so for the whole of Africa. Okay, so again, you've got to look at maybe the 2 graphs to start with, and then pick bits out of the map to get you your more specific information. Are there any places where you think, well, that looks like a bit of an anomaly, I wouldn't expect that to happen? How do the 2 graphs compare as well? And you want to be thinking in terms of timescales, past, present and future, and then also about the idea of spatial scales as well. Not all areas in Africa are going to have a uniform response, and weaker answers will just talk about Africa. They won't pick out and be selective about places on the equator, places above or below the equator, certain country names, you know. So it's about using what you can see and really demonstrating to the examiner that you can analyse the projected rainfall change, because that is what the question says. Using figure 1, analyse projected rainfall change in Africa. So have a go at that. The mark scheme is after it, but don't use the mark scheme until after you've had a go. So that's all I really wanted to say to you. If you feel like it was useful for me to go through this with you, I'm clearly not a professional, then in terms of videoing, then I will happily do some more of these for you. Just let me know via email or on Teams if you would find that useful. Yeah, and have a good rest of your day. And hopefully I'll talk to you all very soon. Bye.